can call plastic ubiquitous, is present in every marine and terrestrial environment on Earth. The concentrations of plastics differ. So in more remote environments, the concentration of plastics are generally less, but it is almost everywhere you look, you're likely to find plastic.
Hello and welcome to Podcast Plastic. It's me, Becky. I'm an ecology student with a massive love of the ocean. And today I'm going to be walking us through one of the biggest threats posed to our ocean and marine environment, which is plastic. In particular, I'm going to be talking about the presence and effects of plastic in one of the most remote regions on Earth, Antarctica. I'll be joined by PhD student Dan Wilson, who is studying the movement of these plastics and the effect it's having on the marine life there. So plastics are synthetic organic polymers, often derived from fossil fuel hydrocarbons. They started being used in the 1950s, and since then global production has increased rapidly from only 2 million tonnes in 1950 to over 380 million tonnes in 2015. And of the plastic that we use, only 9% actually gets recycled. The other 12% is incinerated, and 79% accumulates in landfills or our natural environments. As a result of this carelessness, the pieces of plastic accumulate in our oceans, and then the pieces of plastic slowly fragment and become microplastic, which can be defined as pieces of plastic that are less than 5 millimeters long. Let me introduce you to Dan, who is studying one of the cleanest ocean currents in the world, thought to be a pristine marine environment. It's called the ACC.
It's the Antarctic circumpolar currents, these fast eastward flowing currents that go all the way around Antarctica, effectively acting as like a barrier. But I think it's since the 1980s, plastic's been found in the inner Southern Ocean. So plastic is getting across the Antarctic circumpolar current somehow, but nobody really knows where or how.
So a mechanism called Ekman transport leads to this flow of water around Antarctica, and it results from an interaction between the friction of the wind on the surface of the water and the Coriolis force. It's quite complex, but it creates the ACC, which is the strongest and largest ocean current on Earth, and it's actually so strong that a particle will lap Antarctica in 3 to 4 years. So Dan is studying the movement of these particles as they seem to be getting across the ACC, and no one really knows how. So one way that this could be happening is due to a process called Stokes drift, where a particle that's floating on the surface of the water will experience a net drift velocity in the direction of wave propagation. So basically that means that lots of circular motions will eventually add up over time to make a net movement of particles in the direction of the wave. Unfortunately, not even the air is free of microplastics, as there's been research done that's proven that when waves break and crash, microplastics enter the atmosphere.
I think a recent study I read recently found microplastics on the top of Everest, for example.
So why should we care about the fact that as you listen to this right now, you're probably breathing in microplastics? Well, it's very harmful for marine life. It leads to a process called falsification.
So this is where, because plastics are in the stomachs of, say, fish, they feel less hungry because their stomachs feel full because of the plastic. And if they're eating less, then they're likely to have lower health and lower outcomes.
The debris and microplastics can also become a sponge or a sorbent base for organic compounds such as PCBs. So PCBs stand for polychlorinated biphenyls, and they're a highly toxic compound. Use of them was banned in the UK in 1981, but it's very persistent, so it's still present today. Now, this can lead to bioaccumulation and biomagnification, which is when the concentration of the toxin will increase up a food chain and become very toxic for the apex predators such as leopard seals, orcas and giant squids. As a biologist and ecologist, this is particularly concerning because it's a change which is going to act really fast on a population, so it won't allow time for evolution to act. Particularly in Antarctica, evolution acts very slowly because it's very cold. Therefore, these populations are going to be much more vulnerable to change and may not survive. However, this is not just affecting marine environments.
Microplastics have been found in, I think, the human placenta, and I think it's been found in stools. So we're also likely ingesting microplastics kind of within food.
Hopefully there's no doubt in your mind that this is a massive issue. There are clean-up initiatives acting to try and remove the plastic from the ocean, but prevention is often better than cure. I'm going to leave you today with a few words from DEFRA. Thank you for listening. Hope you enjoyed.
And what we need to do is try to think about the future. And everyone has their part to play, from users to large organisations to governments. How do we solve it all together?